What's going on, everyone? Welcome to this video. Today we're going to talk about one of the main elements in the design manufacturing process, which is the takt time, cycle time, and the manpower. Takt time is how much time I need to produce one product that meet the customer demand. The customer demand consider how much parts that the customer gonna order per day. So the takt time calculation is how much time available for me divided by how many parts the customer is gonna order per day. So the cycle time is how much time I need to complete a specific job per part. The manpower is how many operators I need in the production line. That way that gonna meet the customer demand. So I can still make enough parts to fulfill the customer orders. And the calculation is a sum of the station cycle time divided by the longest cycle time of that stage. So we're going to make a quick example, and we're going to use that example, apply it in a simulation of Flexsim, and find out how does it work. So here I have an example. I have a certain part that I have to produce to customer, and I have a customer demand 1,000 parts per day. The time available is I have one shift running that job, and it's going to be 8 hours per day, and I can just change 8 hours to seconds. To convert that, I have to multiply it by 3,600. So I have a 28,800 seconds available for me. The takt time is how much time available, which is 28,800, divided by the total demand per day, which is 1,000. So I know that my takt time for each part is got to be 28.8 seconds per part. That's my takt time now. The cycle time, in order to complete producing the part has to go through three different stations. Station 1, 2, 3, 1, 2, 3, and then still have to pack the part. So that's going to go through 4 processing. So station 1 is 12 seconds, station 2 25 seconds, station 3 5, and then packing is going to be 10 seconds. So I know now is this line is going to run 25 seconds from part to part. Cannot go any faster than that because the bottleneck of this operation is the station 2. So the OE we have is 90%. So the 25 seconds is my production cycle time divided by 0.9. So I'm expecting to have a rate of 27.7 seconds per part from part to part. So now I can check this. The takt time is always have to be higher than the production cycle time, because if the takt time is below the cycle time, this means that I'm gonna short or shipping parts to customer, because the customer need parts faster than how much I can produce. So I can see that I have 27.7 versus 28.8. It looks like I'm gonna stay okay. So I'm gonna simulate that anyway, just in case. So now we have to calculate how many operators I'm gonna need, or I can still meet the customer demand per day. So I just add up each station divided by the bottleneck, which is 25 seconds, station number 2. So this is mean I need 2.08 operators. We have to round this up all the time. So I need 3 operators total in order to complete the cycle time. So I'm going to use this, put that as an input in the Flexsim simulation, and see how does it work. So here I have station number 1, station number 2, and that's a bottleneck station. This is station number 3, and then we have packing here. So I have 4 operators. I mean, in our design, we actually decide to have 3 operators. I'm going to run it with 4 operators and see what's the output, and then I can just remove the 4th operator and see how does it work with 3 operators instead. Okay, so let's run the simulation. Okay, now the customer demand is 1,000 parts, so we have this order of 1,000 raw materials. And we have 8 hours to run this 1,000 parts. So let's go ahead and do that. So running the simulation now, we have first operator running the first station. and we have the second operator running the second station. We have a third operator running the third station, and we have it's not running anything, it's just packaging on the skid here. Okay, so let's go ahead and speed up the simulation and find out how many parts we were able to produce, or are we able to complete the customer demand, which is here 1,000 parts. Okay, so let's go ahead and run the simulation quickly. So I have 1,000 parts running through the production line, and here I have the throughput throughout. So here I have the throughput, which means the how many parts I'm producing. That's the output of the parts. So far 200, and this is the time. Starts at 8 o'clock, finish at 4. I can still speed up the simulation quickly. Okay, so now I can see that we were able to complete 1,000 parts. That's a customer demand, and we run for from 8 o'clock to 4 p.m. So this line we're able to complete the customer demand 1,000 parts and finish that 2 minutes before the end of the shift. Looks like our model here is working according to the simulation. Since we said we need 3 operators instead of 4, I'm going to remove 1 operator and I'm going to run the line again and see how does it work and see if we're going to have the same output. We should have the same output, but let's find out. Okay, so I have the same output. So we have 1,000 parts was built, and it took until and then finish running the 1,000 parts around 3 o'clock and 57 minutes. 3 minutes or 2.5 minutes before the end of the shift. It looks like we can keep running this line with 3 operators instead of 4. That's all I got for today. Thank you for watching, and I talk to you later.